Hey you guys, here's a quick look at something I didn't quite get to in class explicitly. We did through a different type of problem, but if I say find all the relative extrema of the function, the part I didn't get to without other than that profit function that we did is once you get what the x value is, that's not the end of the story. You also have to plug that x back in to get the y value. It says x, y. Well, that really means x comma f of x. That means put x back into that function of x and tell me what the y coordinate is. So here's how that looks. So if I say extrema, you're still thinking first derivative. Got it. Set it equal to 0. Okay, and then solve for x. That's still the same story. So x equals -4 is where we have a max or a minimum. So one or both of our coordinate points for this problem is going to be -4 comma something. Well, if I look at this a little more detailed, we should decide, well, what is this, a max or a minimum? One way you can do it is the first derivative test we did today. If you're listening to it today on Wednesday, or if it's later, it was Wednesday, you want to test a value to the left of -4 and decide, hey, is my function going up or down? First derivative tells us that. So if I put -5 in to the first derivative, I get out, let's see, what do I get? -2. Well, that's a negative number. That means my graph is going downhill left of -4. And then test something to the right of -4, 0 is a good one. Put it in, you get out 8. That's positive, so it means my graph is going downhill, hits the critical value, then uphill. Picture that in your mind. That means downhill, uphill, that must be a minimum. So it's like a parabola. Well, that's what we have. That is a parabola. We should probably have that tucked away in somewhere in the recesses of our minds, that this is a parabola, x squared, and it's positive, so it's facing up. So that all should make sense. Then it's going downhill left of the minimum there and uphill after. That's why we have a negative and positive for our first derivative done on that first derivative test. And then, that's -4 is where the actual minimum happens. Well, that's only part of the story. That first means we don't have a maximum at all, so you put DNE in there. The relative minimum is -4 comma whatever our output is of the original function, not the derivative, the original function. So put x value into that original f of x. We're going to call it y when we call it a coordinate point. See how low it really is. Where is that relative minimum? What's it located at? So you put -4 into f of x. Carefully use parentheses when you do that, and you should get out, let's see, 16 minus 32 plus 12 for a total of -4. So our relative minimum happens at x equals -4, but it happens also at a height of -4. So that's the coordinate point of the relative minimum. You do the same for any other relative extrema. You have to plug it back in. Hope that helps. Enjoy, and email with questions.